coming to the last part of the last lesson of chapter 2. 2.2. We are solving inequalities with multiplying and dividing. Your learning target today, you can solve one-step equations involving various integers. Notice that integers means positive and negative numbers, okay? So you have positive and negative numbers. Multiplication examples. 3x is less than or equal to 9. To solve this, algebra is all about inverse operations. So you have to solve by doing the inverse, by undoing something. So to undo multiply, what do I need to do? Divide. So I'm going to divide both sides by 3, and I get x is less than or equal to 3. All right, the next one, 5x is greater than 35. How do I move that 5? Divide. 5 times x. The inverse of times is divide, so I'll divide both sides. X is greater than 7. Next one down, 4x is less than 24. That's 4 times x. How do you move times? Divide. I know it's seeming tedious, but
What was that?
what is tedious? Like I'm doing too much, too many little steps. 6x is greater than or equal to 66. How do I move the 6? Divide by 6. X is greater than or equal to 11. Now I need you to take notice. Do you see any negative numbers involved?
No.
There's a reason. I'm not going to tell you yet, but there's a reason. Whoa. Division examples. What's the inverse of divide? Multiply. Fraction means divide. Fraction is all about division. Okay? X divided by 5, the inverse of divide is to multiply. So to undo my 5, I'm going to multiply. What I do to one thing, I have to do to the other. That's the foundation of algebra. Inverse and balance, okay? Cancel it out. X is bigger than 10. Next one, x over 9 is less than or equal to 4. Over means divide. To undo divide, I am going to multiply. I have to do it to both sides to keep my balance. I get x is less than or equal to 36. Have you seen any negatives yet?
No.
Huh, I wonder why. X over 10. Over means divide. The inverse of divide is to multiply. Do it to both. X is greater than or equal to 70. Notice I'm not graphing here because I've tested you on that for 2 lessons so far. Okay? X divided by 2, opposite or inverse, I don't want to say opposite. The inverse is to multiply. X is less than 2. All right. Huh, no negs. I wonder why. Hey, maybe this page has something in common. So flip, you're skipping a page in your notes and you're turning to this one.
Oh, we did skip the negative.
We need to figure out why the heck did Miss Mahol not include any negatives. There is a reason. When you have negatives involved with multiplying or dividing, inequalities, it flips things up. It changes the whole meaning of the inequality. I got this from Lillistrand. What we like to call it is MD&F. You need to MD&F it. MD&F means if you multiply or divide by a negative number, you're going to flip the inequality. You need to know and identify when would I MD&F? When would I flip that inequality? Well, you would do it if there was a negative to the left. And you would do it if there was a negative under it. Because to the left implies that you're multiplying by a negative. Under implies that you're dividing by a negative. That's why. Let me show you 2 explicit examples on how I would solve them, and then you'll work on identifying it, okay? This is just me solving through. If I had negative 5x is less than or equal to 30. To move my 5, I would divide by a negative. But if I divide by a negative, I have this new rule that I have to MD&F it. I have to flip the inequality. So this turns into greater than or equal. Now I can divide through. And I get x is greater than or equal to negative 6.
Why do you have to flip it?
Why do we have to flip it? That is the question of the day. Tomorrow I'm going to show you an actual video. I tried to explain it and I stumbled all over myself. There is a video that is awesome at showing the why, and once you watch it, you're going to be like, oh, this totally makes sense. I'll show it tomorrow, okay? All right.
So today we're not going to flip the
No,
sides?
today you're still going to have to apply it. I'll show you the whys tomorrow.
Yeah.
Negative 5, I already did negative 5. Let's do negative 10x is greater than or equal to 40. To move this, I would have to divide by negative 10. Since I'm dividing by a negative, I'm going to end up flipping the inequality, and I get x is less than a negative 4. That would be my answer. Negative. All right. I worked out 2 examples. Now we need to know when the heck am I going to MD&F something. So we're going to do some sorting. Negative to the left or negative under, you MD&F it, okay? Negative 3 times negative x, would I MD&F that? I'm going to save that one. Let's do negative 7x plus 2 is bigger than 3. Would I MD&F that?
Yeah.
Yes, because the negative is to the left of the variable. So this would be an MD&F-er. I would flip that inequality. 7 plus a negative x is less than 8. Would I MD&F that?
No.
Do I have a negative to the left?
Yes.
I do have a negative to the left. In the end, I would MD&F it. Because I can rewrite that as 7 minus x is less than 8. It's like a negative 1. Negative 1 times x. 3 minus x is greater than or equal to 9. Would I MD&F it?
No. Yes.
Do I have, look at our hands, do I have a negative to the left of my variable?
Yes.
I have a negative to the left, I would MD&F it. 4 times x is less than or equal to 6. Would I MD&F that?
Yes.
Do I have a negative to the left? No, I do not have a negative to the left. I would not MD&F it. I would not do it. Oh! Negative 65 times x is greater than negative 2. Would I MD&F it?
Yes.
There's a negative to the left. I would flip it. I'd flip that thing. I'd flip that inequality. 19 minus x is bigger than 4.
Yes.
Yeah. I'm looking to the left. I have a negative there. I would MD&F it.
But wouldn't you subtract, add 19 on that? Or,
I would, wait, where? I would subtract 19 over. And then I'd have like that negative 1, and I'd have to get rid of that negative 1. 3 minus the negative x.
No.
Oh, good job. I would not. I would not MD&F this because this is 3 plus x is less than 11. And I do not have to MD&F if it's a positive. Okay, next one. Negative 3 times negative x. Would I MD&F this?
yes.
Yes.
No. Because negative 3 times negative x would be positive 3x. That's more challenge questions. All right, let's apply this. Solve and graph. Okay, 3x is less than 12. Would I MDNF this? No, I would not. So I would just go through and solve as normal. Divide through by 3, that's my inverse operation. X is less than 4. Keeping my number line simple, I have 4 and its opposite. Open circle at 4, going to the left. Negative 3x is less than 12. Do I MDNF this thing?
Yes.
Yes. I would divide through by a negative 3. Since I divided through by a negative 3, I'm going to flip that inequality. I'm going to MDNF it. X is bigger than a negative 4. When I first started learning this, I always checked at the end. I checked before and I checked at the end. I checked before and said, okay, I'm going to MDNF it. I checked at the end, are they flipped? Did I flip that inequality? Negative x is bigger than 9. Would I MDNF it?
Yes.
Yes, I would. Because this is like negative 1 times x. Divide by a negative. Flip the inequality, negative 9. Notice that my inequalities are flipped. One more extension for you guys. What if I have this? Well, it's not equal. We're talking about inequalities. Less than or equal to negative 11x. Students got really confused here. Because they're like, oh, but Mahol tells me to put it to the left and all that fun stuff. I'm still going to say put it to the left. I'm going to just rewrite negative 11x. I'm not MDNFing anything yet. Open mouth is facing it. Keep it facing it. 55. Now I MDNF it. If I MDNF it, I'm flipping that inequality, and that's done. Okay. Your homework, last homework assignment of chapter 2, aside from the pre-test, is 2 through 54 even. Page 113. 113.
27 problems.
Yeah, it's not bad.
27.
We're not doing that page.
You can't order the four.
Even.
But you start at 2, so.